The goal of this video is to help familiarize yourself with the different types of pipettes used in a medical laboratory. The video is going to help you differentiate between the various types of pipettes that are used and help you to describe how to properly use them. Lab will give you the experience you need to know how to apply all of this and actually use them during different tests. There are quite a few different types of pipettes, and we're going to just look at the general categories now. First off, we have transfer pipettes, and the two subcategories of transfer pipettes are volumetric and Oswald-Fallen. Then we also have graduated measuring pipettes, and the two categories of that we're going to examine are Mohr pipettes and serological pipettes. And then lastly, we have pasture pipettes, which we're not going to look at again beyond this slide. You're pretty familiar with them. They're basically like eyedroppers. And you can see that usually you don't have a gradation on it. They're not usually graduated. They can be used to measure a drop or so, kind of an unmeasured amount of fluid from here to there. Some of them, if you look really closely, do have little graduations on them, but not all of them. So it just depends. You're familiar with these. I'm sure you've used them in lab at some point before. So looking at our transfer pipettes, the first type that we're going to look at are the volumetric. And volumetric pipettes only deliver one specific volume of fluid. You can't get anything in between. So for example, you can see that this pipette only delivers 25 mils of fluid. So you have to fill it completely up to the line and dispense the whole thing, and you're always going to get 25 mils, obviously plus or minus a little bit. This isn't good if you need to dispense lots of different types or different amounts of fluid, because you can only accurately dispense what is displayed on this pipette. It is used generally, a volumetric pipette is usually generally used for aqueous solutions, so very liquidy ones, not thick ones. And that is because if you notice, the bulb of this pipette is very high up, and because of that, it takes a long time for the fluid to basically drain down the length of the pipette. The thicker the fluid, the longer it will take. So we usually use this for things like standards or reagents, really liquidy types of stuff. An Oswald-Fallen pipette is very similar to a volumetric pipette. It's a transfer pipette, but it's basically reversed. The bulb is towards the bottom, and it also only dispenses one given volume of fluid. And because its bulb is near the bottom, you're going to be able to dispense things that are a little bit thicker. So perhaps the sample, the patient sample. This could be blood, it could be serum, something that is a little bit heavier. You will also probably notice a little bit of a larger bore in the tip of this pipette. But notice how it's got the bulb, like the volumetric, it's just in a different place. And then you have your line as to where to fill it. Now we're going to switch over to our graduated pipettes. And graduated pipettes can dispense varying amounts of fluid. It just depends on the graduations that they have. So the first one we're going to look at is the Mohr pipette. And what you can see here is, for example, this pipette is designed and graduated to deliver up to 10 mils. Usually we use pipettes that are graduated for things like reagents, so usually things that are a little bit thinner, but we can use it for blood, and we will use them for blood in our lab. And if you notice in a Mohr pipette, the increments go from the top all the way to the bottom, except they stop right before the tip. So when you're dispensing fluid from a Mohr pipette, you do not dispense the liquid in the very tip of the pipette. That would be an inaccurate amount of fluid. You have to catch yourself right before the bottom. Or, see, what you can do here is you can either fill as much as you want and dispense to the bottom here, or you could fill to the very top and dispense from the top to however much fluid you want to dispense. So it doesn't really matter how far up you go, just make sure you know that between the two numbers you're dispensing, that's how much fluid you want. So you could fill it to 3 and dispense to 6, you could fill it to 5 and dispense to 8, it doesn't matter, but always remember not to include that little bit in the bottom and to make sure you know exactly how much you're putting in there if you're not filling it to 0 at the top. Usually, as I said, we're going to dispense the fluid between the two calibration marks. Another type of graduated pipette is the serological pipette. This is graduated very similarly to the Mohr pipette, but in this case, you do include the tip in your dispensal. So if this is for 10 mils again, you have 0 here, and because this goes to -1, actually, if you wanted 10, you'd fill it up to -1. But basically, if you want this whole thing, you have to expel all of this fluid from the tip out in order to get exactly how much you wanted. So for example, if you wanted 3.2 mils, you're going to fill it up to here and then drain the thing, and you may or may not blow this air out, or you'll see there's another option as well, but you include the volume in the tip. So that's the biggest difference between serological and Mohr. You can also do like on the Mohr pipette, you can fill it to 0 and dispense that way, and then obviously you don't blow out the rest of it, but you can see that the tip is graduated here. Oftentimes you'll find a larger bore in this one too, because you're delivering, other fluids, body fluids, that kind of thing. So we can use it for reagents, but like I said, it is also able to be used for samples. Now, there's a couple different ways to deliver the liquid that's contained within the pipette. One of those is, and you'll notice that on the pipette they'll have markings to tell you how to deliver it. So first off, if it has the letters TC, this means it's a to contain pipette, and that means you allow the liquid to drain out, and then you will put a puff of air into it and blow out the remainder of the liquid from the tip. So in a serological pipette, you would see, perhaps you'll see this kind. Sometimes you will also suck up a little bit of the fluid again and rinse out the pipette with that fluid. It's not very common that you actually see a TC on a pipette. You probably won't see one in lab, and that's because there's another method that's very similar called a TD, which is a to-deliver pipette. And in a to-deliver pipette, you're going to look at the end of the pipette, and you might notice a frosted band kind of going around the end, basically an etched glass around the end of it. If you see that, that indicates that this is a blowout pipette, meaning you do need to get that last little drip out of the tip of the pipette in order to be accurate. So you'll just use the bulb to puff some air in and blow that little bit out. If there is no frosted band on a TD pipette, then it's considered a drain out. And that means you allow the liquid to drain, touch the tip to the side of the container, and let whatever's left in there drain out, and then if there's some that stays behind, you keep it in there. It's supposed to stay. That's all in the calibration of the pipette. So you can see here, if you look, we've got different markings. This is TD. This also says 10 mils in 1/10. So what that means is this pipette is designed to dispense 10 mils total in 1/10 of a mil increments. Also, this one is nicely noted as serological. This is kind of the same thing, just a little bit larger scale. Note the TD, so this is a to-deliver type of pipette. It doesn't appear to have a frosted band. You'd see a white etching here. So remember, you'll allow it to drain, touch it to the side, and then leave that little bit in there. Again, it's a 10 mil pipette, and it's divided into 1/10 of a mil increments. So the goals of the video was to help show you some of the different types of pipettes we use in the lab and give you a little bit of information on how to use them. In lab, you're going to get that experience and you can ask questions then. Thanks.